These are the lightning talks for Surge of 2015. It's an event that has had a long history here of being, I think, a lot of fun. We don't do the standard format of 2 minutes, 2 minutes, 2 minutes. We've opened it up to 5 minutes. Thank you, Bryan, for correcting me again. And they can be funny, they can be serious, they can be just about anything. And sometimes they're very surprising. I want to thank Robert and the rest of the team for allowing me to do this and putting together such a great conference. I want to thank the sponsor, AppNexus, for making this possible with the support they gave. And without any further ado, we will start with our first talk. It's a gentleman named Dan McDonald, and he's speaking about 2 future internet directions.
My name is Dan McDonald. I'm with Omniti. Omnios is my day job. And I'd like to talk about 2 upcoming directions that the academia and research sectors of the internet community are working on. Most of you know what the internet architecture looks like. It's the protocol hourglass, where you have your apps on top, your transport protocols, and your presentation protocols, your transport protocols, and then you have IP in the middle of the hourglass, and then it widens back out again over various links, over various physical media, until you get to the bottom again. And modulo the larger addresses of current deployment of IPv6, things really haven't changed all that much since 1981. 2 future directions that are being worked on by groups in the IRTF and in academia in general, they are orthogonal to each other, but they could end up affecting people in ops. At some point, I think the first one will be medium term and the second one will be long term. The first is the separation of location and identity in IP packets. And basically it's an improvement on the protocol hourglass where IP gets a little better. And then named data networking, which they are going to reshape the hourglass and put a different thing in the middle narrow waist. IP addresses today basically serve 2 purposes. It's a locator. As it transits the backbone, it tells you how you get there. So that's a not so random IP address that pretty much if you send one from here will transit the backbone, exit at Verizon in New York City, and eventually hit northern Massachusetts. It's also Kibi.com. It's my public web server and one of 5 zones on my home server. Why not separate the identity and the locator out from each other? Nodes become uniquely identified independent of location. And if you can imagine that, not that AWS would ever go down, but imagine if AWS West goes down and you can reinstantiate your very node with the same identifier, just with a different locator in AWS East. And if you're really good, you could keep those 2 nodes redundant state up to date with each other. It is even theoretically possible, depending on latency and how fast you can update things, you could even, especially for longer-lived TCP connections, even keep the connection state up and running. Alternatively, with separating out location and identity, you can have mobile nodes with real mobility at the IP layer, something that's eluded real world for a long time. And there are probably more things you can do that I haven't thought about yet. There are 2 proposals out there. The Identifier Locator Network Protocol, ILNP. I'm a little biased toward this one because Rand Atkinson is an old friend and he hired me out of grad school. So that's RFC 6740. It's an experimental RFC, and it basically splits the IPv6 address into identity and location components. The Locator ID Separation Protocol, which has the colliding acronym of Lisp, is done by Dina Farinacci and a bunch of other people from or associated with Cisco, and it basically will do an IP packet inside an IP packet. So for IPv4, you'll have an IPv4 space that's identifying and an IPv4 space that's locating. And those will both go along in a single packet. Looks like a tunneled one, perhaps. The other approach to internet futures is the named data networking, where you're going to refactor the hourglass. All the apps are still on top. You have security, and then you have what are called content chunks, followed by a strategy for disseminating those content chunks. Traditional protocols are near the bottom, and then you hit physical again. There's a big research group associated with this. You can visit their page at namedata.net. Van Jacobson started this as a project at Park, and he's expanded it to include more of academia. You're universalizing content chunks, and all middle nodes become store and forward nodes. It looks a little more like Usenet or email than it does traditional IP datagram switching. Data objects are assembled from chunks, and they are signed. So it will make all objects end-to-end secure, because when you receive a full object, you can check it against a signature. Yes, there's a lot of infrastructure that's going to be involved with this, but that's why this is a longer-term future and something still in academia. And personally, I'm imagining ZFS equipped middle boxes everywhere, and maybe they're running Omnios, and maybe they're running Manta or SmartOS/Manta or something. We'll see. I'm kind of excited about that possibility. And I've got 10 seconds left. Thank you. Any questions or get off the stage? Anything? 2, 1.
All right, Dan, thanks very much. Next will be a friend of mine for a number of years, Abel Matthew, on the subject of debuggability.
Yeah, so I'm Abel. I work at a company called Backtrace, and we actually think about debuggability quite a bit. It's not a question that a lot of people ask themselves, but it's something that we do. And in particular, we've been asking ourselves the question of how do we compare compilers? And that's because some of the people that we work with, they're thinking about switching to C-Lang versus GCC. One of the questions that they don't ask themselves is, what about debuggability? They really care about compilation time, executable performance, what error messages they're getting, which is a pretty popular one for switching to C-Lang. But they don't ask themselves, does this affect debuggability? And so I wanted to take, a minute to actually describe an experiment that I ran, actually this afternoon, that essentially what it did is it measured the number of resolved variables. And what I mean that is I walk through the stack trace, and the variables that are reachable, I see whether they're optimized out or not. And so I'm comparing GCC 4.9.2 versus C-Lang 3.6.0. And this was what just came on Ubuntu 15.04. So app here is actually just an internal app, just something that we use at Backtrace. I wanted to see what happened. So with no optimizations, you're seeing something on the order of near 3,000 resolved variables with GCC versus something like only 1,200 versus with no optimizations with C-Lang. On that same app, you're looking at 1,700 with O2 versus around 500. So this is actually a pretty significant difference. Where this matters is, let's say you're doing post-mortem crash analysis. You're looking at a core dump. If those variables are optimized out, the less information that you have, the harder it is to figure out what's going on. For people that are on ops teams here, if your developers are asking, like, hey, let's switch to C-Lang, this is something that they should consider. Then what we did is I just took Node.js master, and I compiled it with GCC versus C-Lang, and I wanted to see the difference. There, you're getting around 1,600 versus 475. So still pretty significant difference. This is obviously a pretty quick experiment, but what I wanted to do was follow it up with the blog post because it's pretty interesting. As to reasons why this is happening, it's not necessarily C-Lang's fault or GCC, what GCC is doing. It might be something with GDB, it might be something with the debugger that you're using. So yeah, follow the Twitter, and hopefully we'll post the blog post soon. Yeah, I went that pretty quick because I was told I only have 2 minutes. So any questions, anything?
You can tell a story for them.
So here we're actually using a tool that we built at Backtrace that is essentially a debugger. What it does is it uses libunwind to actually walk through the stack trace, and then it uses dwarf information to actually try to resolve the variables. Just locals. Just stuff on automatic. Cool. All right, thanks for the time.
Thank you, Abel. Next up will be Dave Pacheco, I hope I pronounced that right, with what I think is going to be disaster porn on something titled Manta's Bad Day.
All right, thank you. My name is David Pacheco. I'm an engineer at Joyent. I'm going to be talking about Manta's Bad Day. This is a talk about an outage. I wasn't sure how I was going to jam it into 5 minutes, but I was inspired by Bryan's tweet on that day, which is actually just a 2-word postmortem for the outage, which is wraparound auto vacuum. The funny thing about it was we were not the first company literally in that week that had a major outage that was related to a wraparound auto vacuum. If you've never heard about this, it's probably because it's never hosted you in production before. If you use Postgres, at some point it may, and then you will wish you remembered this talk, but you won't, because the only way you can remember about wraparound auto vacuum is to have actually experienced an outage as a result of it, as far as I can tell. So this is about the Mantis storage service. This is an object store that we run. It's put, get, delete of byte blobs over HTTP with a Unix-like directory structure. Mark Cabbage and I gave a talk about this at Surge 2013. And it's a strongly consistent system. It's built heavily on a Postgres-based metadata tier. So we have a bunch of shards for scalability, and then each of the shards has multiple Postgres databases for availability. And basically everything in the system, both all the data path operations and the compute jobs that you can run, all access this metadata tier. So the outage happened at 10:30 UTC on July 27th, and what happened was clients are starting to see very high latency, followed by a bunch of 500-level errors. It's a kind of a classic case of client makes a request, there's a problem internally, the API servers time out after 2 minutes and send back a 500. We were able to tell pretty quickly that the problem was on one particular Postgres database, and simple queries to that database were totally fine, like select now is totally fine. The database itself is not hosted, but all queries on this one table, which we use for Manta, were totally stuck. In fact, there was only one query in the entire database that was not currently blocked on locks for an extended period, and that was an auto vacuum that started at 10:30, which is obviously an interesting coincidence. Turns out this was not our first issue with auto vacuum. We'd had a whole bunch of issues related to insufficient auto vacuuming. So if you haven't used Postgres, I don't want to get too into the details, but vacuuming is a process by which it deals with tuples that are basically, they were part of a table, but they're no longer part of a table, but they might have been visible to some transaction concurrent with the one that removed them, so they don't get removed right away, so you have to do this asynchronous vacuum operation. But because that's kind of hard to manage automatically, they've added an auto vacuum system. But occasionally we've seen service problems resulting from auto vacuuming running, or I shouldn't say, we hadn't root caused most of them, but auto vacuum was on the scene. The outage was either resolved before we were able to root cause them, or we just canceled the auto vacuum without figuring it out, which is obviously problematic, but there we were. So we thought in this case, well, maybe canceling the auto vacuum will help, but we want to be able to root cause it. So I tried to grab whatever data we could from the PG logs table, which shows you what's blocked, and then we restarted Postgres. And this worked. It was great for about 10 minutes. And Postgres immediately kicks off another auto vacuum, and this time we notice it's specifically to prevent wraparound. This is a much more specific issue. This is what Postgres considers kind of a more critical form of auto vacuum, where it's much more aggressive about database locks that it's holding. And if you read the documentation on this, it's a little scary. What happens is you have these transaction IDs. It's a 32-bit number, so it's a 4 billion space, but it's a circular space, so there's 2 billion on either side. And if you wrap around, then you have things that were supposed to be in your past that look like they're in the future. It's really bad. The database shuts down. So that's what we understood at this point, so we said, okay, we actually do have to let this thing finish and do its job. But is there anything we can do to speed it up? So we start looking at it with the tools that we have, and we see that the Postgres process, which is doing all the work, is actually spending most of its time sleeping. And that's kind of weird. And at first we see, we're tracing the kernel scheduler. This is one of those cases where people are like, I'm building an application. Why do I need to trace the kernel scheduler? Well, because your thing is sleeping all the time and you want to know why. We were able to figure out that it was sleeping on I/O. And the problem is it's reading a whole bunch of files, and it's doing sequential reads of a file, which file systems are generally pretty good about prefetching, but it's also reading tons of files in the same directory, which were also sequential, but the file systems don't generally know about that. So we were able to prefetch those and speed it up quite a bit. The next thing we did, we found it was actually still sleeping a lot, but this time it was in a mechanism within Postgres called the cost-based vacuum delay. This is a mechanism that's there to prevent the auto vacuum process from taking over all the resources on the system. And so it literally just like sleeps every period of time for a little bit, which is exactly the wrong thing to do here, because this was literally the only process in the database which was not currently blocked on this process. So that was actually exactly the wrong thing, which was unfortunate. And there's no dynamic way to change this, but it's our computer. It's all just memory, right? So we just use the debugger to whack these global variables, and we get a 5x improvement in read throughput. So we're doing the prefetching for a couple of hours. The auto vacuum completes. The service comes back online. Everything is great for about 10 minutes. The auto vacuum kicks off again to prevent wraparound, and it's exactly the same state, exactly the same table. At this point, we're thinking we need a new approach here because this is not converging at all. And so we look back at the Postgres stuff to get a little bit more information, and we find that although it kicks off, this problem happens at 2 billion, Postgres kicks off this emergency operation at about 200 million, which is considered conservative, and that's what they talk about in the docs. It's conservative from the perspective of this problem. It's very aggressive from the perspective of our thing is actually down right now because of the auto vacuum. We actually wish we hadn't dealt with this right now. We ended up tuning that tunable up to 500 million, and everything came back, and that did work. We're still there. And then we went and figured out why was our service totally hosed at this point. The fun was just starting. So that was a 10-hour outage. I spent about a week trying to understand everything that happened. We were able to figure out what the problem was. And the high order bit for people using Postgres is the auto vacuum process and the wraparound auto vacuum process does not intrinsically cause your whole data path to go down, but there are certain things you could be doing as an application that are very hard to know that you're doing that will actually cause exactly this problem. So all of the details are, I knew I was going to be out of time at this point, all the details are in our postmortem. Definitely check that out if you're interested for more, or come ping me. Thank you.
The next talk is by Dimitri Carbonas, and it's called, and this was a suggested topic name, and I thought it was a good one, Ruby on Slime.
That was actually the punchline to one of the few jokes in my presentation. Thanks, Gare. Well, thank you all for coming. This is Otto. My presentation is called The Future of Biological Computing, or Overhyped Sludge. And my only qualifications coming into this are my own curiosity, and hopefully by the end I will have piqued your own curiosity in this subject as well. Perhaps you've woken up one morning to find a strange orange or yellowish foam growing on a lawn or on a tree. This is called a slime mold. It has no brain. It doesn't belong to the animal kingdom, the plant kingdom, or even the fungus kingdom. So the term mold is actually a misnomer. It's a collection of single-celled organisms, eukaryotes, that bear resemblance most of all to amoebas. It grows in a network structure. It's a self-organizing system, and it's capable of complex behavior. And this last bit has been responsible for a great deal of buzz online about slime molds. For example, it's responsible for such blog titles as, "Why My Slime Mold is Better Than Your Hadoop Cluster." It turns out this probably isn't the case. But where did this sentiment come from? There's sort of a canonical study on this where this dot in the center is the mass of the slime mold, and the surrounding dots are little bits of grain that have been scattered around it in the formation of the subway stations in the Tokyo subway system. So this slime mold starts spreading out its tendrils to consume this nourishment, forming a very dense network. Eventually, it starts pruning the non-essential edges of this network so as to have an optimal configuration of sorts. It turns out that this structure actually mirrors the design of the existing Tokyo subway system to a great deal. It's actually more optimal. And it was later discovered that the model used by Taro here for this study will eventually converge to the optimal solution. I stretch eventually because there are some caveats here which we'll get to. In the general case, in other words, you can just throw down a bunch of grains and the slime mold will find the optimal configuration. So there's also research done in computing with slime mold. We can shape slime mold into arbitrary structures. We can actually grow NOR gates out of it. That means you can construct any circuit you want out of slime molds. There's a project called PhiChip, not PyChip, that is dedicated to growing slime mold chips, both in the analog style of computing in the Tokyo subway system and more of a digital style of computing in terms of these NOR gates. As far as I know, they haven't made too much progress, but we're hopeful. So, like I said, there are some caveats. Slime mold grows at a rate of 1 centimeter per hour. It's dubious to how useful this is, right? And if we can make NOR gates out of slime molds, why go through this trouble when we can make NOR gates of better quality and quantity today? In fact, in all of your devices right now, you have orders of magnitude more of these gates than we can practically make with slime molds. Additionally, going back to this network optimization problem and these strange smarts present in this slime mold, This is appearing sort of in a tradition of where we look to physical processes for potential help with computation. I guess the epitome of this is quantum computation. But it turns out that typically these physical processes don't give us very good solutions. The most popular example of this has been by Scott Aronson, who showed that if you take soapy water and throw it over some spools embedded between glass, the soapy water is not going to arrive at the minimum Steiner tree. In other words, it's not going to be able to compute an NP-complete problem nearly instantaneously, as some people said who were spreading rumors. This is somewhat true, or true as well for the slime mold. It's not going to be able to solve NP-complete problems for you, but experimentally it's been shown to be able to arrive at an approximate solution for a traveling salesperson, which for an organism with no brain is pretty impressive. This is a slime mold solving traveling salesperson. You can see toward the end it begins to look like something. So what are the possibilities? Could we have autonomous circuits living in nature that are self-assembling, self-healing, adaptive to change, have a low raw materials cost and no electricity cost? We really don't know. Right now, we can't. Of course, observing slime mold in the laboratory is, of course, a legitimate use. Observing it form various structures in various circumstances and observe what happens. But can we come up with anything now? So I'll offer a few suggestions. I think offering up slime as a computational resource leads to new complexity classes. Primarily, my question is, how much of the Earth do we need to cover in slime to solve a given problem? The size of the slimeable universe is finite, and we're running up against the physical limits of computing here. You might ask a question like, how many continents have to be engulfed in slime to solve for the clique problem on 1 million nodes? I find that this usually results in very productive conversations. If we don't have access to very good computing, we can always market it as artisanally branded, all-natural, analog biocomputing, slow computing, sourced from local forests. And I suggest we produce a Ruby on Slime project. I think we can get a lot of people on board on the slime mold revolution because there's always the tagline, because you're already using Ruby. And here we observe the use of slime mold in art. This might be one of the most interesting applications. Here, music professor Eduardo Miranda is performing a piano duet with slime mold. I wish I had music for you. Thank you.
Generally, lightning talk is a night full of mysteries.
It's a night full of mysteries.
And we'll just put this behind you.
That's cool.
All righty.
All right, I'm
Welcome.
literally running the examples off my phone. This is fabulous. This is as prepared as I was. I came up with this lightning talk literally in the hallway about an hour before it was time to give lightning talks. And I am going to talk to you about grammar. Because, you know, why not? We talk about all kinds of other things, and grammar's just as scalable as anything else. In my real life, I'm an engineering director, but I have a second life where I am a professional writer, and I write all of the time. And I spend hours and hours and hours editing writing, and then I go into work and I read engineering writing, and it makes me die inside. So, and then what happens is I sit down and I take their writing and I attempt to edit it. It's usually in Google Docs, and you know what Google Docs will let you do? Reject people's changes. Magnificent. So this happens to me all the time. So the number one problem that really is facing engineering writing is that you are terrified of your subject and you are terrified of your verb. It is literally going to leap out of your computer and strangle you at any moment. Or at least that's how you all write, which is great. So this is called writing in passive tense. I have a whole bunch of examples here that I'm going to try to edit up on the fly so they're a little bit more surgy. So there's two kinds of ways of writing a sentence when dealing with a verb. There is active tense, in which the subject acts directly on the verb, and there is passive tense, in which the verb acts on the subject. The trick of passive tense is that you want to get your subject as far away from your verb as possible so nobody actually notices that you just wrote this sentence. And that is how most engineers write. So I'm going to attempt to edit some sentence for you literally on the fly without prep while I stand here. So you're getting the quality you paid for, which is nothing. So, first example. We'll actually use the example that's on my phone because I really like this example. So the first example is that at dinner, 6 shrimp were eaten by Harry, right? So as long as we don't know that Harry ever ate those 6 shrimp are safe until we get to that period. And we can refactor that as Harry ate 6 shrimp at dinner. Now we know what Harry's doing. He's eating shrimp. In fact, we can go to the thesaurus right now, and we can punch up that verb and make that sentence way more interesting. Harry gnawed 6 shrimp at dinner. Harry just gurgled on 6 shrimp at dinner. These are fantastic verbs, right? The next example, the data center is roamed by beautiful network engineers. Not the sentence on my phone. We know the data center is there. We know somebody's roaming it. We don't want anybody to know that the network engineers are in there. We'll edit it for them. Beautiful network engineers roamed the data center. Now they're there, and you'll know where you'll get rid of them. So let's find a buy. Here's a good one. Monitoring is going to be watched by us tonight. So we know there'll be monitoring, and eventually it'll be watched, and eventually we'll get to us, and it'll be tonight. Or we can say, we are going to watch the monitor tonight because our systems will probably crash. And this allows us to convey more information very quickly. Short and punchy sentences are the secret to actually getting your subject across to your audience. It also shortens your sentences, makes them easier to read, easier to digest, and you will have more audience longer, and they will retweet you on internet, on Twitter. I tell you right now, you want tweets, active tense. So how do you get rid of some active tense? The word by, if you use that, we were watched by, yeah, that by, that's a signal right there. Were, anything that has to be in it, to be is your enemy, right? We should have been doing something. We don't want anybody to know what we were doing, but we should have been doing it instead of just doing it. Could be, must be, anything of that ilk, really terrible. I only have 45 seconds, so I want to rant about my other favorite subject of engineering writing, which is adverbs. Don't use them. They are bad. Just get it in your head. So if you see practically, yeah, erase that word. Only, get rid of that word. Very, yeah, that's awful. The word just, yeah, you just kill yourself. Don't use that anymore, right? Just edit it out. 20 seconds. There's an app online called HemingwayWeb.com. It teaches you to write like Ernest Hemingway. It's awesome. It will tell you how bad your writing sucks, how many adverbs you have, how much passive tense you have, how many run-on sentences you have. If you work with this app, I guarantee you, you will not have me ranting at you on stage at Surge anymore. So engineers, learn to write. We can write well. We can do it together. Yeah, go team. And that's great.
So next, we have Josh Smida with the mysteriously named talk, Jackalope.
This talk is also called Bad Ideas. Maybe just ideas. Hey, I'm Josh. I'm also a CTO. I'm also hiring. First, power. Hey, this is a tech conference. Where's the power strips? Why do I have to stand here in the hall to charge my terrible laptop with a terrible plug? I mean, seriously, Apple? What? You guys are supposed to be a design company. Get your shit together. All right. The thing I was watching the Braintree talk about the wonderfully named Broxy. Not that Jackalope's a whole lot better, to be honest, but it's a unicorn with rabbit you'll see in a sec. So, like, the idea is we want to do SOA. We want to have, services in the internet with, like, a communicating pattern. And I don't want to drive my ops engineers insane. So I drove them insane in a slightly different way, and I wrote a whole new, like, application server. So the idea is you get traffic from the internet through your web thing into your Ruby thing, because yeah, this is Ruby. And then there's a little thing there called AMQParty, which basically acts like HTTParty, which is an HTTP library, that actually talks to Rabbit, even though you think you're talking to HTTP. And then on the other end, instead of like your web app being run by an actual like decent rack server like Unicorn, we run it on Jackalope. So at Jackalope reads off Rabbit and fakes out HTTP, and you can run your Ruby stuff. And it's cool. And this is actually working. We actually have this in production on one tiny little app, and it didn't totally drive our DevOps people crazy. They're just a little bit crazy to start, so that's fun. Anyway, so this is a lot like how Broxy, I guess, is structured similarly, except they were using Redis, which is better. Anyway, we're probably not going to go forward with this. I gave a talk about this at RailsConf a couple years ago, and everybody was like, oh, that's great. And now I'm like, yeah, we didn't do that, really. So move along now. Anyway, the thing that really kind of broke this was, ignore the Rubies, mostly this. Yeah, Rabbit is not really scalable and does not tolerate network partitions well. That's right there on it's the first sentence on this doc. I mean, that's just, you had one job, man. So maybe a better idea, still probably crazy, thing I'm thinking about, I'd love your input. So you still, get the traffic API server, then it talks actual HTTP to something, which might be written in a halfway decent language and not actually a portal to hell, Bryan Cantrill, that writes to Kafka and then is read from via Kafka and fakes HTTP on the back end. And then we do some wonderful packet mangling to route the traffic right back to the original client and not actually go back through all that pattern. So this is kind of like percolating through my head right now. If you know how to make this happen without me having to write a lot of Haskell, I'd love to talk to you. Or if you think this is a great idea and want to help out, I'd also like to talk to you. Anyway, that's it. Thanks. I'm Josh. Good luck.
Hi, I'm John. So I spent a couple months of my life earlier this year writing a memory allocator in user space. It was somewhat complicated in that it packed everything together. There was zero fragmentation between allocations. I knew that going in, but that meant that a lot of tooling, like Valgrind, wouldn't work as well, because an allocation that goes off the end of its space and overflows into another one, you can't catch it. So this was generated by basically the following quote: let's write a new memory allocator to support that. And that's how I spent 3 months of my life writing a new memory allocator and shoehorning it into a moderately high-scale production application. My favorite definition of existentialism is a sense of disorientation or meaninglessness in an apparently absurd world. And that's basically how you feel when you're debugging a memory allocator in production, especially when you can't use Valgrind on it. So debugging a memory allocator in production when you can't use Valgrind on it and don't have any good tooling is basically, to me, like standing in the middle of Times Square in the middle of the day, finding a pile of dog crap in the middle of a crosswalk, and your only recourse being to stand there and wonder, who has done this? Oh my God. And that's all you can do. Eventually, you figure it out, maybe. But maybe you have to stand there with a microscope on the crosswalk and examine every foot that walks by. Who knows? I'm going to use the 5 stages of grief as a way to talk about memory allocator and the process of writing them. So denial, yeah, I mean, you think that. It'll be easy. That's fine. You're done. Writing a memory allocator, it turns out, a complicated one at that, is easy. Debugging it is really hard because you were arrogant. So then of course, comes anger. We all know how this goes. You've been there. Bargaining. Please. Red zones. No one started the timer, by the way, so I'm just going to keep going. Can I have red zones? Can I build red zones? That might have been a good idea when I started. Anything, really. Literally anything that allows me to use Valgrind, or if Valgrind's too slow for you or you like better error messages, address sanitizer, great project. You need a modern compiler, though, and that's something I can't always have. Bargaining, definitely a good stage of grief. Depression. At this point, you start rewriting the entire memory allocator from scratch, building in proper hooks for tooling and proper ways to integrate things like user-level red zones. So you start rewriting half of what ASAN has already done for you because you can't use ASAN, or you write good hooks for it. At some point, you get so depressed that you wonder, why bother with this? Why not do something else? I've got exabytes of address space. Why not just hand out random pointers? And that's what I tried. I tried that. It's right there. It works pretty well. You allocate a terabyte of address space, and if you hand out random pointers, it works great until you allocate about 10 megs of space, and then you start to see corruption. What's that? Exactly. So if you just need a real, terrible toy program, just hand out random pointers. And the last stage of grief is acceptance. You've realized that you were arrogant. You've accepted that. You wrote some proper hooks. You wrote some user-level red zones. You read the ASAN paper front to back, re-implemented some of it, and really you just have to remember that you shouldn't do this in the first place. J.E. Malik is really great. They've done a lot of work on it. And that's all I have. The timer also now says 0, so don't know when that happened. But thank you.
His talk is titled, Native Don't Scale. All right, thank you.
Thank you. So I work at AppNexus. Mostly what I do is I make things fast. Whoa, what's going on here? All right, and one of the things I keep hearing is we could use C++. Templates, you get very specialized code, it'll go fast. And let me tell you about caches, friends. But this is getting worse now because we're all doing big data. What I hear these days is we're going to take our machine learning model and convert it to machine code, and it'll be really fast. And now I don't know if I should scream or weep, especially when it's your CEO telling you that. So this, or drink, yes, that happens a lot. So this is a rant that usually goes through my head as I hear these things. This is a picture of a die for Xeon E5 that we run in production. It's an amazing piece of engineering. You say things like, we're constrained by the speed of light here. If we want to go faster, we're going to have a smaller chip. And this is what it has to communicate with the rest of the world. That's 2,000 pins. That's all we have. Of those 2,000 pins, a lot go directly to DIMMs, and DIMMs have about 240 pins. That's not a lot to move around terabytes of data. In fact, if you look at the bandwidth we have on our production machines, we can run about 5 bytes per cycle per DIMM. That is not a lot. Now, let's look at a piece of code that is pretty much ideal for current processors. That's a DAXP, so you do AX plus Y over vectors. And what you find is that you have more bytes of instructions than bytes of data that it accesses. So we're all used to thinking, oh, it's going to be slow. It has to go through all of this data. But if you also have to go through all this code because you decided to convert the machine learning model to straight machine code, you're going to spend most of your time waiting for memory, not even for your data, but just for the instruction to know what to do with that data. So I ran an experiment. I'm like, all right, let's see what happens when I have huge basic blocks of just knobs. And as we see, even with 1 kilobyte basic blocks, as you hit main memory, you can do about 1.5 instructions per clock. That is very much the ideal. And those are 1 byte instructions. As we saw here, most instructions on x86 are about 3 to 6 or 7 bytes. So we're probably looking at about 0.1, 0.2 IPC as your code is not in cache anymore. This is amazing performance, as you all know. Normal business code gets around, 0.8, 1.5 instructions per clock. So it's just, 5 times that slow. And there are 2 reasons for this effect. One is, well, you keep jumping around in random memory. So while we're used to thinking, oh, I'm making random accesses, it's going to be slow. Well, you have the same problem with code, except it's even worse, right? Because if you don't have code, you don't even know what other data you could be prefetching or looking at. There's no speculation anymore. You just turn your fancy 2015 computer into something that's out of the 90s. And then there's just, well, there's no bandwidth. Cache, amazing bandwidth. That's L1, L2, L3. Then you hit the main memory, and you have something like 1/4 the bandwidth. So yes, if you want to scale, please don't tell me you're just going to turn it all into machine code.
With that, I will leave it to Andrew Wong and his Untitled lightning talk.
Hello, I'm Andrew. So as Gear alluded to, my professional career has been a series of mistakes. Some of them more or less painful than others. So there are two options here. There are software developers and ops people here. There's also like a human interest part to this story we could tell. So which one do you want? The operations, the software developer, it's basically Pager, or the human interest story? Not everyone speak at once. Human interest? Okay. So, not really a planner. Did eventually plan something in my life, though. And about a year ago, we decided we'd have a kid. So we didn't, I didn't tell the company I worked for that this was happening. I discovered it and then spent about 9 months keeping it a secret. Yeah, that is funny, isn't it? So towards the end, so I was in New York and my wife was in Copenhagen. And I mean, it's 8 hours across the pond. It's not that bad. She did most of the work. So I showed up about a month before to be supportive and not risk serious divorce. And I went through this, told the company that I would show up in a bit, I'd be back. So Halloween, my daughter was born. I spent the night before that patching some code that had broken production. Show up to the next meeting, the all hands, or not the all hands, but the team meeting, and I raised my daughter, and it's wonderful. I mean, it's great. If you don't have kids, I'm not going to encourage you to do it. It's something you should come to on your own. Some of the fellow team leads almost fell out of their chair. Others realized that I was probably more responsible than I let on. Others probably thought I was really actually super irresponsible. So a leading question that you get when you have a kid is, how much worse is Pager now? Because you don't really have, like there's one thing that you actually care about, and then there's like Nagios. I know some of you are thinking I named my daughter Nagios, but I didn't. So Pager was actually really good prep, at least in the organizations I worked on, because pages start slowly. There's 1, 2, dies down, you think you're saved. You're like, oh, whew. Some poor other idiot reached for his phone first. And that's really what raising a kid's like, right? Like it's a battle, especially when the sun is down. It's first person to wake up, that's it. You're on duty, which is hard if you're a programmer because you're already up. So I can attest that Pager is worse, and it really wasn't that bad because I had someone to keep me company when everything was breaking. and they were really happy to see me. Unlike the machine, which was an uncaring silicon god with no forgiveness. None at all. The other one you can feed or sing to, and it gently stops yelling at you. So that's my talk. I hope you enjoyed this human interest story. If you have any questions, you should ask them in the next 19 seconds. Anyone but Robert. I mean, it doesn't look very friendly. I mean, no one else is sitting near you. But okay, Robert, take it away. No, actually. Not Nagios, not Zirconis, not Omnios, not SmartOS, not Linux. Named after a Greek god, Ariane, who was the goddess of a maze and kept a minotaur. Any other questions? Excellent. Goodbye.
Mr. Treat, which is a treat. I was really happy and surprised that he volunteered to give a talk, which is topical. Yogi Berra, unsung.
Yeah. Normally I might not do that. Ready? Okay, good. All right. Hold on, slow down, stop. It's backwards. All right. So Yogi Berra. So I sort of felt compelled to say a few words for this man, who's a great man, who I don't think gets enough credit, especially at technology conferences. I really haven't heard too many talks about him, and I think that's a shame. So here to set the record straight. We've credited a lot of people over the years with whatever the heck DevOps is. I've heard a lot of people talk about it. A lot of people say they know what it is and who created it and where it's been and what it's done. A lot of people attribute it to Gene Kim, who wrote the Phoenix project. Kevin Baer, George Spafford also worked on the Visible Ops book with Gene, so they also get some credit. I've heard people say like Allspa is like the originator of DevOps or something like that, or he's one of the new fathers or something. So there's a lot of credit going around. Teiichi Ono worked in Toyota manufacturing. Goldratt, another sort of person who's done a lot of work that is sort of attributed to being legacy info on DevOps, if you want to learn that. I think probably the person who gets the most credit, I'm not sure it's deserved. John Willis tells me it is. Deming is the guy who really invented DevOps, right? So if you want to learn what the core principles and truthiness of DevOps is, like you go study Deming, and that's the way of the future. However, like I'll give Deming some credit, like he's there. You can probably reverse engineer his principles into DevOps, that's cool. But I think the person, again, who always gets left out of the conversation is Yogi Berra. And Yogi Berra had a lot of good things to say about technology and a lot of good things that I think directly apply to the world that we live in and to DevOps as a whole. For example, this is one of his most famous sayings, the future ain't what it used to be. And that's so true. If you think about it, you know, when you go and like think about like waterfall and agile development, it's our attempt to try to deal with this kind of a problem, right? The future ain't what it used to be. We come up with plans, we do like rollouts and all that stuff, and it never ends up the way it's supposed to be, right? And this is the kind of thing, like I say, it just totally gets overlooked. Amazon, web infrastructure, right? We've all heard about it. Many people here use it. Many people think it's a great thing. You know what? I don't know. If I was starting a business today, I probably wouldn't use it. Nobody goes there anymore, right? It's too crowded. Use Joyent. Nobody's using that, right? Like you're gonna get all kinds of, you get all the bandwidth and I/O and whatever you need. Like it's great. I would totally do that instead, right? So, but think about it, like that whole resource contention is a thing. So you got to think about that when you're trying to like deploy and build systems, right? Keep in mind what Yogi's told you. He's tried to lay this all out. For years he's been saying this stuff. The nickel ain't worth a dime anymore. Have you seen anything out of Silicon Valley that kind of, follows like modern laws of physics when it comes to how much it's going to cost? Whether it's developers or houses or, the BART train and getting a burrito, like all of that stuff, way crazy overpriced, doesn't make any sense. It's just insane, right? Technology industry, it's lost its mind. And Yogi knew this. Yogi foresaw this. And that's what's important. One of the things I would say You can't stop all mistakes from happening, right? That's totally true. I always try to tell people on my team, like, hey, try to screw up in ways that don't hurt you, right? And I'll admit that I basically have plagiarized this from Yogi, right? It's okay to make mistakes, that's fine. Just don't make too many wrong mistakes, right? Those are the ones that are bad. Good mistakes are the kind that we hear about at Surge conferences. And I encourage you to make those kind of mistakes, because that's what we need more of in the industry. Absolutely. Another thing you hear a lot about when it comes to DevOps, it's all about monitoring systems, measuring, sharing that information. You know who said that first? Damn right, Yogi Berra. You can observe a lot by watching. I've done this before. I've watched all kinds of things, and I observed so many of them, and it's just so true. Like, these are fundamental truths you cannot disagree with. So like I said, Yogi Berra, unsung hero, he passed away this week. That's why I'm bringing you this news. As you're out on the town tonight, or whatever National Harbor is, as you're out on the town tonight, don't forget to pour one out for Yogi. He's given so much to us. It's time that we take a moment to reflect upon him and realize his greatness and study his teachings. Thank you.
So everybody knows, who knows Theo? Okay, so Theo was a founder of Omniti and founded this conference. He's I guess slacking off for a year or something. I think he's wandering around the world, and this is his first SurgeCon that he's ever missed, and he was sort of broken up about it and was tweeting about that. There was an AWS outage over the weekend, right? And traditionally, Amazon would hold their fall outage during SurgeCon. But this was a problem from the organizers because it would, sort of make your experience with Surge not good every year. So they asked, and apparently Jeff Bezos complied, and they kind of moved the outage to before you got here, so you'd have the time to drink out there on that town thing that Robert mentioned. So, what could we do? Because this is recorded, sadly. And what could we do, for Theo? So we thought that for Theo, we should do an interpretive dance of the postmortem of the weekend's outage. Cannot believe I'm doing this. Oh, I'm just going to read stuff. Oh, no, I'm not dancing. No, you are, yeah. So I'd like to get a few volunteers. Seriously. Come on. Let's go. Some people want to do this. It won't go to your bosses or employers. Yeah, you got people. And the funny thing is we have a bunch of shills, and now we have people that are not shills, so we really don't know what's going to happen. So, yeah, great. Thank you all for volunteering. For Theo. For Theo.
I didn't dance at my wedding.
Well, we could do this at your wedding again if you want to. All right, so what I have here is I took the postmortem notes that were put out by Amazon's marketing department, apparently. And I cut them down a little bit to try to get to sort of important pieces. And what we're going to do is interpret them, read them to you, so it's kind of like a postmortem, you understand what happened, but augment that with some interpretive dance. All right, so I got to get out of the way here because I don't want to block this. Oh yeah, no, and in all honesty, this is completely unrehearsed. We talked about it, a few of us, should we rehearse? But we felt that art is best spontaneous, and actually, because we actually had no idea what to do to rehearse, so. Yeah.
I actually danced for 3 years in college, ballet. So.
Fantastic. I'm down. Fantastic, okay, so there will be a role here, which was sort of like the prima donna, which in this case is the metadata service. So you as a professional dancer, I guess, do you need a pole? Okay. All right, great. So it was called the DynamoDB event. How many people actually use DynamoDB, or you did use it? Okay. All right, so on Sunday at 2:19 a.m. PDT, there was a brief network disruption that impacted a portion of DynamoDB's storage servers. Okay, some of you need to volunteer to be storage servers, like say 4 of you, and sort of be storage servers. All right. Fantastic. Now, when this happened, a portion of the metadata service, you there, responses exceeded the retrieval and transmission time allowed by the storage servers. So storage servers, what are you going to do about that with the metadata service? I mean, the requests are good. As a result, some of the storage servers were unable to obtain their membership data and removed themselves from taking requests. All right, that's good, storage servers. You need to knock. Some of you should remove yourselves, but we still need storage servers, so maybe 1 or 2 come back. Good. Multiples, you know what you could be? A multiple simultaneous request. Multiple simultaneous requests for these large memberships cause processing to slow further and eventually exceed the allotted time limit. This resulted in disrupted storage servers failing to complete their membership renewal, becoming unavailable for requests, and amazingly, some of them were retrying these requests. With the metadata service now under heavy load, it can no longer respond as quickly to storage servers uninvolved in the original network disruption. Were you involved earlier? No? Okay. We need to be precise with these postmortems. Where was I? Great. Unavailable servers continue to retry requests for membership data, maintaining a high load on the metadata service. After several failed attempts at adding capacity, at 5:06 a.m., we decided to pause requests to the metadata service. That would include reducing the load. This action decreased retry activity, which relieved much of the load on the metadata service. Okay, there got to be some load then. With the metadata service now able to respond to administrative requests, and this is where we need a couple of people to help out, we were able to add significant capacity. Storm the stage. Significant capacity, come on! I guess it is Amazon, so it's slow to spool up significant capacity. Right? Okay, at 7:10, DynamoDB was restored and error rates low enough for most customers. I guess they have very low standards. And AWS services depend on DynamoDB to resume normal operations. Next year, we will talk about Elastic Beanstalk. We are done. For Theo. Okay. We have our last one. And this has become another sort of unspoken, unwritten tradition, because mainly we write this stuff down the day of. The last talk is going to be by Bryan Cantrill. And I think this is actually the first talk that I've ever seen him do for a lightning talk where he actually knew what he was going to say before we started the talk. So, Bryan Cantrill.
Thank you.
Oh, it's autoplay. You got it
That's
back?
right.
Okay.
Yeah, not being sorry about the autoplay. Hey, how are you? So just so you know that there is, what Gear did not mention is that there is a Cantrillian exception to this little time limit here. But I think it's an advisory. But I promise I won't bore you as I walk you through what I did not name, but was named in history, a crime against common sense. So this crime against common sense, sorry, I'll because I won't wander from the mic. This crime against common sense begins in our implementation of LX-branded zones. So if you didn't see my talk earlier, one of the crazy things that we've actually managed to pull off at Joyent and in SmartOS is the implementation of a Linux system call table on top of SmartOS, such that we can actually run Linux binaries in a SmartOS zone, which has been terrific. It sounds great. It's great. It's great when it's done. Okay? It is hell on earth to implement, and we have all earned 10,000 years of lightning talks in implementing LX-branded zones because we've implemented Linux in all of its horrors, all of its semantic atrocities have been implemented because we can't actually argue with the application. We have to simply get it working. So this is, and actually, honestly, the most difficult part of this lightning talk was figuring out which atrocity I was going to go into depth on. So, and this is actually quite difficult, so hopefully I picked the right one. But if I pick the wrong one, don't worry, we can just get me spooled up on something else a little bit later. So what I'm going to talk about is an application called Plex. I've never even run Plex. I don't know what it is. Apparently it's something that fellow nerds run at home. I don't even, like I said, don't know. It's a video, something or another. All I know is that it is a entirely closed binary that runs on Linux and didn't work very well on LX. In particular, it would blow up in very strange ways. So this starts actually, this is in January. This is a chat transcript with Patrick as P. Mooney. Patrick's in the room. I'm not sure where Patrick is. And so Patrick is looking into this LX core dump. And one of the challenges about implementing LX-branded zones, implementing a Linux system call table, is that when you get it wrong, the application often just dies. And it dies in some absolutely batshit insane way. So this thing has died, Plex has died in a way that makes no sense, and we've actually gone back to the vendor, apparently, and extracted a binary that's actually compiled with debugging information. But of course, like most compilers, if you compile with debugging information, that actually means I actually want you to generate the worst code humanly possible. And Patrick is saying, am I crazy, or is this overly complicated for what it accomplishes? And the code that he's referring to, I'm going to show you to in a second, but just to continue the transcript, Robert says, I assume this is not an actual assembly thing. Patrick says, I can't say for sure. This is Plex blowing up in LX. But to their credit, these binaries actually have symbols and frame pointers, unlike most of the shit we have to deal with. It's a fucking Shangri-La, says Patrick. To which Robert says self-demerit. You may wonder what that is. Robert is assigning himself a demerit because he has been trolled by what Patrick has just said. And you can see, and in particular, there's something that's very, very important here. Between those two things, note the time latency. So that 2133 says it's a fucking Shangri-La. Robert has been trolled into rage about the fact that there are no symbol tables and there are no stack traces and there are no frame pointers, so most of the things we've done, has done no productive work and has now come in line to say self-demerit and assign himself the demerit, which I tuned it out here, but the chat bot reported his number of demerits. So that's what's going on, just to give you a little bit of backstory there, what's going on there. Okay, as it turns out, Patrick is not crazy. This is the actual gist that he was mentioning, and I'm actually relieved that I am not the first person to show assembly during the lightning talks. I'm also not the first person to talk about libgemmalloc, but I'm not going to reflect it nearly as positively as was reflected earlier. So libgemmalloc is, I mean, I'm not going to say trash fire, but I guess I just did, but now, this is not, to be fair, I think this has to be unoptimized libgemmalloc. I think this has to have been compiled under duress because nothing else explains what's going on here. I'm going to move Q, this looks complicated, but I'm going to walk you through it. I'm going to move Q, this crazy address that ends in D80 off of the base pointer. I'm going to load something into RAX. Got it. I have loaded this value from memory into RAX. Okay, that's fine. And now I want to take RDX, a different register, and I want to move that into 0x10 off RAX. Okay, fine. I'm just highlighting that there. That's fine. Okay, we're happy with that. Now I want to move this same other memory location back into RAX. And this is one where, like, you wish the microprocessor could just stop and be like, you mean the one you just loaded? You want that one? Yeah, I want that one. Do you think it's changed? No, probably not. Can I just give you the same thing I just gave you? Yeah, you can do that. Okay, asshole, here it is. But of course, the microprocessor can't just do that. The microprocessor has to suffer in silence, and it simply gives it. But then this gets so much worse because then I'm gonna move hex 10 off RAX into EAX. Okay, fine. And now I'm gonna move EAX into EDX. So it's like, well, didn't we just do that? All right. But apparently these things are not crimes. The microprocessor has to just run it, so on we go. Okay, so Patrick is not crazy, but Patrick is also frustrated. We're frustrated. We got a bunch of random core dumps. We can't make any, other than being mildly amused about terrible assembly, we can't actually make any forward progress. But then some good comes of it, in that Patrick is so frustrated that he does actually notice that we don't have support for FS space in the core dumps. He puts that back, which I thought was pretty great, but it meant that we couldn't actually make any forward progress on the actual problem. And here's a chat discussion where we're talking about I love the fact that you've added FS space in the core dump, and Patrick is saying, yeah, I can't actually debug it though. I'm not actually closer to knowing what's going on. And this is what I love about chat transcripts, is there are always like 8 conversations happening at once. So if you take just a small subset of them, one of those conversations will come swooping through, and you can just be kind of amused by it. So Robert, seemingly apropos of nothing, says, one day we'll replace Kimu's I/O paths, and it'll be glorious. Like a fortune cookie that fell from the ceiling. You're like, okay. Meanwhile, Gemmalloc is crashing. But it's like Robert's got a point. One day we will replace that, and it will be glorious. But Patrick had this beautiful, beautiful theory about what was going on. Unfortunately, that theory was contradicted by the data. I hate it when that happens. So it was a beautiful theory. It was so nice, but it was wrong. So we're not any closer to knowing what's broken, which is awful. And then some time later, we get a very interesting report. And actually, this I would take a quick aside. This is a report from someone in the community. This was tremendously helpful to be open source, because people are doing different things. And one of our users, in fact, one of the users using Plex, reported that the Gemmalloc tests, the unit tests, bail out. So we've got all these random core dumps. We know that Gemmalloc is always on the scene, being always linked into the program, not necessarily on the scene. And the fact that the Gemmalloc unit tests can't complete, okay, that is definitely interesting. And so if we can actually, because Splunk is dying, Plex is dying, and boy, if we can do this with the Gemmalloc tests, let's go figure that out first. So this is a great place to start. There's another chat transcript. One of the things that we've also decided, whenever anything dies randomly with LX, we're always nervous that our Futex implementation is wrong. What we have learned from this is that our Futex implementation is definitely right, but we always blame the poor Futexes. Futexes, by the way, will be the subject of 10,000 other lightning talks. Unbelievably god-awful broken, but whatever. It's implemented correctly here, so it's got nothing to do with this particular problem. But so we're going to kick off some Futex stress tests. That'll be fine. And meanwhile, we're kind of dividing our work here, and we're going to go actually look at these Gemmalloc tests and see if we can understand what's going on with the Gemmalloc failure. Okay, this sounds good. Great, go, super. And we find a test that dies really reproducibly, which is great. And it dies reproducibly. It's a pretty simple test. And I'm looking at the system calls that it does. And there's an madvise with mav don't need that it's doing. And that's a little weird. Madvise, you want to kind of look into this a little bit. And so let me just remind you about what madvise is. So madvise is an old POSIX routine. These old and POSIX become important in a moment. And madvise is advice. It's advice. That's the noun that is associated with the verb advise. This is foreshadowing. And you can give a lot of advice, but because it's advice, it can be ignored. That's what advice is. And that's the difference between advice and a fucking command. This becomes important in just a moment. So this is madvise, which says here's a memory region, and here's the length, and here's the advice I wish to offer you. And the advice, and this is actually a great thing, because what is happening here is the application is trying to tell the operating system kernel something that's very difficult to infer, namely, what am I going to do? It's very hard for the kernel to actually predict the future. If the application can say, like, hey, psst, here's what the future is, that's great. We can actually act. So madvise, it's a great idea. The idea of it providing advice is terrific. And madvise don't need. Now, admittedly, this slide is Spartan for a reason. This is all POSIX says about mav don't need, which admittedly is a little on the terse side. Specifies that the application expects that it will not access the specified range in the near future. Okay, that's a little light, but fine. Mav don't need, I don't need it. I don't actually need it. I'm going to go back to my previous slide just for a moment, because I'm going to point out that this is advice, and in particular, if Mr. Prompt will go away. It's covering up what it's saying here, but it is to have, there we go. If you look at that last line, the POSIX madvise function shall have no effect on the semantics of access to memory in the specified range, although it may affect the performance of access. Fine. So mav don't need is saying, I don't need it, but it's still mapped in. That's some advice. That's some advice. Okay. This is the Linux man page for mav don't need. Okay, it starts off somewhat promising. Do not expect access in the near future. Now, this is like classic Linux man page pigeon in that, are you using the imperative voice in there? Are you telling me that I should not expect access in the near future? Or does that denote what the flag does? Okay, let's just leave aside the man page pigeon, because this actually has many more complete sentences than most Linux man pages, so we should give it that. All right, for the time being, this is also a very strange thing. For the time being, the application is finished with the giving range. It's like, we're talking about a tense disaster here. For the time being, like in the current tense? What are we talking? Anyway, for the time being, okay, the application is finished with the given range, so the kernel can free resources associated with it. Uh-oh. Subsequent accesses of pages in this range will succeed, but will result either in reloading of the memory contents from the underlying map file, or zero filled on-demand pages for mappings without an underlying file. Boy, does that not sound like advice. So what this is saying is that when you say mav don't need, I'm actually fucking saying munmap. That's the same thing as saying because if you're done with it and you don't need it again, and we need it again, it can be B0'd, then why don't you unmap it? Well, that's not advice. Unmap it. That's a command. That's a system call. But no, okay. So this is a very strange, and this is kind of okay, please let this be a bug in the man page. Please, it can't be this dumb. It can't be this dumb. It can't be this dumb. No. So this is a very simple program that demonstrates what I'm talking about. So we're going to mmap something. We're going to map it private, map it non. We're going to set it to a value, 123. I'm going to give you the advice that I don't need it, and I go back to read it again, and it's 0. Now, this is not what mav don't need is supposed to do. What mav don't need does is it says, I actually don't need this, and if the system needs it, it can take it. Mav don't need actually does violate even the POSIX notion of semantics. If the system needs it, it can take it. But I have no right to expect that it is 0 when I go back to it. If I go back to read it, if the system needed it, it will be 0 filled. If not, it won't be. It'll be the old thing that I stored. I can't rely on the fact that it's 0, which it turns out is exactly what gemmalloc is relying on. And the reason this is so unconscionable semantics is that the way mav don't need is implemented is actually very clever. What mav don't need does is it takes this page and it just puts it on the list of pages that can be reclaimed by the system. It doesn't have to do anything else. Whereas mav facepalm over here has to actually go through the memory system and actually effectively free the page, get rid of the page. It's a lot more work. So it's stupid. Why would anyone need this? In fact, it's so stupid that you want to know, I went Googling for it to be like, okay, am I the only one upset by this? This happens a lot. I'm like, please tell me someone else is enraged by it. So you Google madvise mav don't need, which I encourage you to do. It's pretty funny for Linux. So you Google madvise mav don't need Linux, and you find all sorts of things about how broken the semantics are. You also find this question, which is the top hit on Stack Overflow. Does madvise mav don't need instruct the OS to lazily write to disk? It's like, oh, God, you know what? You've been told, questioner, your entire life that there's no such thing as a stupid question. But that's a lie that smart people tell you. There is such a thing as a stupid question, and this is one of them. You need to have nothing to do with words like memory, data, write, disk, OS. You need to, and I'm not saying that you don't have the right to live a full life and to raise kids and to be happy in this universe, but you may not call mav don't need. I'm sorry. Because, no, it doesn't do any of these things. This is so wrong. Leave aside my little, rant on stage about the difference in some inside baseball semantic difference between Linux and other operating systems. This has just got nothing to do with what you think it has to do with. And you read this, and you're like, oh, God, what's the answer to be? Oh, God, please let the answer be, oh, thank God. Oh, one of those one-word Stack Overflow answers, no. For your own good, stay away from mav don't need. Actually, for your own good, stay away from mmap, actually operating systems, computers, stay away from the whole lot. Maybe you can move to a compound in Idaho. I know someone looking for a roommate out there. But it actually goes on to explain that Linux will not take this as a hint to throw pages away after writing them back, but to throw them away immediately. This is not considered a bug, but a deliberate decision. And finally, I'm finding my people. You can feel the simmering anger in there. And it's like, God bless you, Damon. You may even be in this room, Damon, whoever you are, because you are clearly upset about this. And goes on to explain the irony and about how actually there was something to go do this, but they don't do that. And you will lose data if you use Mav don't need, so don't do this, essentially. So then you keep looking for this, because you really want to know who is to blame here, and do the Linux kernel folks appreciate how broken this is? And you find that there are many posts like this, but I like this one. Wrong M-advised Mav don't need semantics. This is in 2005, so digging back a little bit to history. Where did this come from? And this person says, hi, there's something wrong with the current M-advised Mav don't need. Both the man page and the source code say that Mav don't need means the application does not care about the data, so it might be thrown away, but that's not what POSIX says. I'm not sure if they screamed it when they wrote it, but I'm screaming it now. And so this person goes on to say, every other operating system does it, and actually points out that Solaris has Mav free. And I know that Solaris, I know it's the S word on the Linux kernel, but Solaris has something called Mav free. Mav free does exactly what you want it to do. So Mav free says, actually, I'm done with this, and you can actually go free. You can actually invalidate it. So we actually have something to go do that called Mav free. Like, why don't you use Mav free, jerks? But maybe we should add Mav free, and we could change the semantics of Mav don't need to be the proper semantics. And by the way, the man page should be corrected too. It's like, yeah, the man page should be corrected. Absolutely. Then we started on that. Okay. So Robert Love in Novell says, I like the idea of renaming the current Mav don't need to Mav free. Okay, that's good. And then adding a correct Mav don't need. Oh yeah, glad everyone likes this in 2005. What the hell? It's 2015. Have we not fixed this? And as I said, the man page needs clarification. Like, okay, all right, everyone's weighed in. Okay, that's like, so can we go please make this happen? No, apparently we can't. And then this person responds, and God love Yearn, I don't know who you are, because when I read this response, I was still a little angry. And he responds, in my opinion, this is still a crime against common sense. And it's like, God bless you, Yearn. It is a crime against common sense. And so the man page needs clarification, definitely says Yearn, absolutely needs clarification. Where did this come from? And I didn't mean to give it away. Where did this come from? Who did this? Who is to blame? No other operating system does it this way, right? Wrong! True 64, what? What? Seriously, what? No, honestly, like what? Seriously, True 64, what? All right, so this is a mail from August 20th, 1999. And now we're getting to where this came from. And SAP was doing what people do at SAP and what people were doing all over at the time. And they were getting their app, their Unix app, to work on Linux. And one of the things they were missing was Mav don't need. And poor Hans, or Christoph, I guess, poor Christoph did not mean to do this. But Christoph accidentally referred to True 64's implementation. So we need something like AIX's disclaim or True 64's M-advise. Wow, AIX v True 64 in a semantic duel. Like, which one are you going to root for there? In this case, the right decision was AIX, my friends. Go figure. Sometimes it is the right answer. So he's saying, like, listen, this is what we need to go. You should add Mav don't need. And he says M-advise is known in many systems, but they do not agree about the meaning of Mav don't need. That's putting it euphemistically. Actually, they do agree that True 64 is doing something else. Most of them only use as a hint to page this area out. Perhaps a flag Mav free or Mav disclaim would be better. Disclaim is AIX specific. Not another system. All right, what are the comments here? And the response to this is someone says, well, wait a minute, Mav don't need, it seems like True 64 has the wrong semantics. And although I like M-advise, I must admit this interpretation is a really odd misuse of the M-advise function, which is in for speed optimizations only, but to remove the mappings of any semantic at all. And he says, yes, I think you were right. The True 64 people misinterpreted the call. Okay, so because some poor True 64 engineer misread the call, and that fire managed to leap the fire line into Linux, because Linux implemented it this way anyway. It's like, oh, mommy. And so that's what happened. It came from True 64. True 64 is what crashed Plex on LX branded zones. All right, so what about Mav free? Can we add Mav free? Well, yes, we can actually add Mav free to Linux. And this is something that, this was finally suggested in 2014. So fast forward from 1999, maybe we should support M-advise Mav free. And then they did some benchmarking with libgemmalloc. Hey, turns out libgemmalloc is a lot faster when we do it this way. It's like, yes, you dummies. If you'd implemented it properly in the first place, you wouldn't have this problem. So, of course, you're like, okay, great, it's done. Well, no, it's not done. It was done. It hasn't been integrated anywhere. It's 2015. It's a year and a half ago. But Linux moves so fast, man. It's like, yeah, right. Okay, so keep waiting for MAB free. But don't worry. It's been fixed in the man page. We'll drop the sentence that the kernel may ignore advice. So in the man page, it used to say the kernel is free to ignore the advice because it's fucking advice, and the bug is determined to be, well, the sentence is the bug. We should eliminate that. Oh, mom. Anyway, there I fixed it. Madvise, it has now been fixed for everyone running Linux. There you go. Thank you.